I'm Aaron Myers. I am the group lead of the GE Informatics Engineering Group at Outage National Lab. And today I'm going to be telling everyone about our Eagle-Eye platform and some of our open utility data collection and analysis. So for the next few minutes, I'll give you an overview and history of Eagle-Eye, talk about our transition from commercial off-the-shelf to open source, and talk about some of how we're collecting the data and how we're using that data to support some of our open science initiatives. So Eagle-Eye is the environment for analysis of geolocated energy information, because we're quasi-government and love an acronym, so that's what that stands for. This is DOE's operational platform for situational awareness of utility outages. So we currently cover about 140 million customers as reported by EIA. So that's not people, that's customers for utilities. That's about 93% of the US and territories. We do actually cover Puerto Rico and the Virgin Islands currently. Our primary users are federal government, but also supporting state and local emergency responders. This is for the emergency response function number 12, which is the energy sector, which is part of FEMA's National Response Framework. There's a lot of things that go into this. So this is kind of a quick org chart. Everything, so we have a data team, we have infrastructure and analytics. All of this information flows up into our web application, supported by our web team that creates this Eagle-Eye program. So we have about 30 people supporting this effort and helping us to create these new capabilities to support emergency response. So how did we get here? So back in the early 2000s, there was a fairly major blackout in the Northeast United States into Canada. And at the time, the Secretary of Energy said, how many people don't have power? And it started with a few thousand, and then a few 100,000, and then 1 million. And we couldn't get a clear answer of what that was. It really showed a kind of a lack of situational awareness as it related to the energy sector. From that, the national labs got together and supported the Visualization Modeling Working Group. So this was kind of cutting edge at the time, was desktop analysis, throw it into a PowerPoint, send that to decision makers. Then ORNL developed a capability called Verde, which is another acronym, visualizing energy-related infrastructure dynamically on Earth, I think is what that stood for. In this one, we actually had NDAs, non-disclosure agreements with utilities to get line status information. Really good information. Problem, can't share it. So we really couldn't even share it with the Department of Energy, and so that became a challenge. DOE decided that they wanted to take that capability back to DOE headquarters, and they rebranded it as Eagle-Eye, and we continue to look at ways to support emergency response using open source, and that's where we created the EARS capability, where we started doing web scraping and collecting outage data from the public. In 2016, DOE said, hey, Oak Ridge, we think you can do this better than we can. So they moved Eagle-Eye back to Oak Ridge, and we kind of undertook a significant modernization progress. And in 2017, we actually released that update. So when we got Eagle-Eye back in 2016, it was Esri-based Microsoft SQL Server. It was actually written in Flex and Flash, which even at the time was a deprecated technology. And so we looked at it holistically and said, we know we need to make this better. We need to build a platform that's sustainable, that's capable, that's up and running all the time, that we can start to modernize and really tailor it to meet our user needs. And so we kind of looked at the world back in 2016 and said, we have commercial off-the-shelf solutions, we have open source solutions, what should we do? So we looked at how do we make this cloud friendly, how do we provide good user authentication, how do we not get tied into a vendor? You know, companies come, companies go. We don't want to have to keep changing things out. And also, since we're supporting the federal government, we didn't necessarily want to have a whole bunch of licensing costs to maintain this application every year. So we did a trade-off analysis, and open source won, partially because we have a lot of experience at Oak Ridge dealing with open source and developing web applications using open source technology. So the top was our 1.0. As you can see, it's Microsoft SQL Server and Microsoft Reporting Services. At the time, it was, it ran on 2 VMs. If one of those things went down, we were completely dead in the water. So when we looked at it, we said, let's use Docker. So we wanted to use containers, allow us to deploy at multiple places, deploy across multiple systems. If we needed to burst out into the cloud, we would potentially have that opportunity. We built it using Java, Spring Boot application. All of our data collection is written in Python. And one of the core capabilities that we develop all of our applications with is APIs and open geospatial standard services. So GeoServer gave us those OGC services, and then all of our Java web applications created GeoJSON and JSON services that people could consume into their own applications. You don't have our interfaces. We think our interfaces are pretty good, but we want to make sure that we're not a data silo, that we can share that data out. And then one of the things that as we moved into containers, we said managing Postgres in a container is hard. It's not as stable as we want it to. Enter crunchy data. They said, hey, we got a container that you can use. And that's become kind of the backbone of a lot of our database support. Our databases are supported using those crunchy images. And they actually provide support for our databases in general. So how does our data collection work? So there are 450-ish utility outage maps that we're currently collecting data from. So every 15 minutes at 0, 15, 30, and 45 of every hour, we kick off a process that goes out and scrapes all of that data set, pulls them into our Eagle-Eye database, and then generates them into the outage map. When we first got Eagle-Eye back to Oak Ridge, that process took about 12 minutes. That's the reason we do it in 15-minute increments, is because that gave us enough time to get the data in. When we moved to open source and you started utilizing a singleton Docker container that does this data collection, we're now able to collect that data every 3 minutes. And a lot of the slowdown in that is actually using Selenium. So we actually go open the web page, click the browser, virtually click in the browser to get a table to open so we can read the data. And that's the thing that slows us down. We could probably do it even faster if we didn't have some of those constraints. Utilities love to change their outage maps. So a big part of our process is monitoring, maintaining, and keeping those collections up and running so that we get the best situational awareness possible. So we collect data at the point, polygon, zip code, county level. So whatever the data is available, that's how we collect it. Points and polygons are really good. That gives us a lot of information. Zip codes are challenging. Zip codes cross state boundaries. They cross county boundaries. They do very weird things. They're really not a great spatial unit to do some of this analysis at. So we're very cautious on when we actually can have to collect at that level. But that's something that we're doing a lot of analysis on how to make that more accurate. And then at the county level, that's the most common way that we collect the data. And that's typically also how emergency response is handled is data. So we pull all that information together. We run a summarization process that pulls it together and creates this national outage map that you'll see at the bottom. The gray areas are where we actually don't have any coverage. Green means that we're actually covering at least one utility in that county. Gray means we don't have any. So we're doing pretty good overall. So the next generation of data collection. So we've made some good progress. We want to make it even better. So enter another open source technology, Apache Airflow. So this is going to help orchestrate that data collection even further. So we will grab the utilities that we need to collect them. We'll spin up single workers, worker pods that go collect those. We're not going to do 450. I think it's 450 divided by 20 is what we're going to end up doing. It'll go out and do all that collection, and then run through, create CSV files, put those on disk, and then another process will come in behind it to actually do that summarization and push that data into our database. Why are we doing this? It's more for maintenance and scalability, so that we can, again, if we need to collect faster, if we need to collect more utility, it's going to allow us to grow, that we can utilize these open source technologies to make that even better. So since 2017, these are some of our major milestones. A couple that I'll go in deeper here. Modeled county customers was a big one. And then before that, outage override. So this is a situational awareness platform. One thing that often happens, especially for small utilities during a hurricane, is their server loses power, their outage map goes offline. And so when our responders have better data than what we're able to collect, we can actually override that stuff. We've done site redesigns. We allowed the system to work for our responders, creating customizable alerts. And now we're starting to get into more of an analytics capability. So Jessica mentioned this earlier in her talk. So we just this year released our historic archive of outage data. So we have data from November of 2014 through December of 2022. Every 15 minutes for every utility that we collected data from. That data is accessible to the public for use in research. And then our process moving forward will be that in January of every year, we will release the previous year's data. So in January of 2024, we'll release the 2023 data. There are ways to get data more frequently, and I'll kind of probably talk about that towards the end. So model county customers. So when we first got Eagle Eye back, you could only look at it at a total customer count outages, which for very small counties, you would never see them as having a significant impact. So we needed to level the playing field so that you could actually see where these significant outages were happening. So utilizing some of our USA structures data and some of our expertise in population modeling, we took the customer information, disaggregated those into buildings, and then created a way to model county customers. And so taking all this information, using PostGIS and Postgres to create a process that annually we update the number of modeled county customers. Now we can look at percent outages across the nation. And so you can start to see those really small counties that might only have a few hundred or a few thousand people. When they have 30, 40, 50% outages, those things actually show up on the map. And so the other thing with the county customers data, the service territories is a really big challenge. We have to find really good ways to combine together the customer data and then what we know from outages that we've collected to create a better service boundary that we can disaggregate those customers into. Now that we have this platform, we can start to ask more questions. So looking at this historic data, we're starting to look at trends. So one of the common questions that we get for using our data is how do we do energy justice evaluations? So we're starting to kind of look at this problem of how can we utilize this data. But we need to start first by breaking down the general assumption that all outages are bad. So what we're trying to look at is kind of take that approach and say, what's the normal behavior of a utility within a county? How can we map that? And then how can we look for deviations in that? So if we want to look at normal behaviors within a county or for a utility in a county, we can actually, if that utility covers multiple counties, we can look at those behaviors and see if they're actually different. And if they are, we can actually start to try to ask some of those energy justice questions. Why does this one utility behave different in neighboring counties? So this is some work that we're just starting to do, starting to look at where do we see significant numbers of outages. You would definitely expect it in the summer. That's hurricane season, but also most air conditioning runs off of electricity, whereas in the winter, you get multiple fuel sources. And so you get a lot of different, so the strain on the energy infrastructure tends to go down in the winter. So there's some kind of expected patterns that we're starting to see. So one question you might ask is, why does a national lab need to be in this business of utility customer outages? And it's really because we have a lot of expertise outside of this. So one of the things that we've really developed here at Oak Ridge is an event reach back support capability, where when the president or whoever the decision maker asks a question that our responders have a challenge to answer, we utilize all of our resources to help them answer the question. So the Texas winter storm in February of 2021 is a great example. Eagle Eye wasn't meant to answer the question of how many customers didn't have power for more than 4 hours. That's because that relates to SNAP benefits. So if your refrigerator doesn't have power for 4 hours, the general assessment is you should throw everything away. And so we took the data, we got some of our statistical brains together to help us come up with an algorithm that gave levels of outages, so significant outages that were longer than that 4-hour duration. And so starting to look at some of those questions. Kentucky tornadoes, looking at at the maximum outages. Tornadoes are an interesting one. They don't always cause big numbers. They're cause very localized information. So we have this capability where questions can be asked back at us, and we can pull together the resources to make that, get those answers done. We're starting to build in more analytics. So this is an interesting one where we are doing utility pole detection. So we have a drone, it's a quadcopter. On that quadcopter is a machine learning algorithm that, as it's flying, is looking at all of the pole structures and trying to assess, is it good? Is it damaged? What are we gonna do with it? And so that data goes directly from the drone and streams back into our Eagle Eye platform on the fly, so we can get that information out quicker. And so that kind of leads us into one of the core goals of Eagle Eye moving forward. And all of this that you see on this slide is going to be built off of open source technology, is how do we go from data to decision making faster? So we'll have drones in the field. We're developing UAS kits that can be deployed with our responders, and they're going to have a lot of capabilities in the field to get information, assess that information, and actually have it in the field, maybe even in a disconnected environment. Once they're connected, this Mapster capability runs on the laptop, and any geospatial data that's put on that laptop will get streamed back to our system so that we can actually start to do more analysis with it. And we can also, if our partners has a UAS system or a drone, they can also feed us data. That's going to go into a big image store, and then we're going to utilize the very large compute infrastructure that we have at the lab to do more analytics, create more data, and then use Eagle Eye as a platform to push that data out to our decision makers. So ideally, we can go from that drone being flown, collecting the data, analysis being run, getting that workflow from weeks down to hours. And that's one of the big capabilities that the Eagle Eye platform and the open source technology is helping us to utilize. And with that, I'll take any questions. Yeah, so the question is, are we seeing a lot of data science and information utilizing this data, and what is it saying about it? We're just starting to get into some of that analysis. I know Georgia Tech and the National Renewable Energy Lab has been doing some research. I think what we've seen anecdotally, just by being involved in this and utilizing this system, is states that get hit with big weather events are getting a lot better about restoration. So I'm not necessarily sure that they're improving their infrastructure, but they're being able to get it back online faster. For Hurricane Ian, I think, Florida was restoring power almost as fast as it was going out. So you didn't see those big, long outage lines. They were much shorter. So I think there's definitely, the infrastructure, it's hard to tell if it's getting better, but the ability to restore it and get those things back online is actually getting improved significantly.